Okay, this is part 2. I'm going to pick up where I left off. Let's see, from current slide. There we go. So don't be afraid of subqueries. It's a query plus a query done together. So let's see some different combinations of this. So remember I was mentioning before that this is an equality, which means this subquery can only produce one answer. If it produces more than one answer, we have to use it like a set or like a bag. You're like, uh-oh, this is relational algebra. This is the part of the schedule that was called relational algebra. No biggie. It's not really math. Don't worry about it if you have a math block. But it's not even math, actually. A set is a unique grouping of items where no duplicates exist. A bag is everything in there with duplicates. You just have a bag, a container, and you just throw a bunch of stuff in there. You can have 2 of something, 3 of something. So if you're working with regular queries, you're going to get bags that come back. And if you're going to get a bag, you're trying to check to see if a value is in the bag or not in the bag, which is what the in means. And this up here says row, not toe. So row is in the relation, and the relation is going to come back with a grouping of items. Is true if and only if it is a member of the relation, or it's not in, which means the opposite of being in. So an expression is going to appear in the where clause, and the relation is often a subquery. So here's our example. From beers that have name and manufacturer and likes that have drinker and beer, find the names and the manufacturer of each beer that Fred likes. So we're going to select star from beers where the name is in, and this is the new part here, name in, which means it's in this grouping. If it's in the grouping, we have a match. And the grouping is the set of beers that Fred likes. Well, we're going to select beer from likes where the drinker is equal to Fred. Pretty simple query. Pretty simple query. The in is what's doing it for us. So it's in this grouping. So select beers from likes where drinker is equal to Fred. Well, the likes, he might like the same beer at multiple different bars because he frequents multiple different bars and he likes beer. So, because Fred's a drinker. He's in the drinker's table. Yeah? What's this, the what? This one here? It means everything. It's an asterisk that means select all columns. So what this is going to return the columns that are in beers that Fred likes. Digest. Think about it. So we have in, not in, just like the like, not like. So we saw like and not like with the wildcards for pattern matching. The in, not in for the bags. Is it in this bag? Is it not in this bag? Is it in this group or not in this group? And then we have exists or not exists. Meaning, does one of them, is there a match in anything? Does it exist? Is it possible or not possible? Is basically what it means. So exists, whoops, wrong direction. Exists is true. If and only true, the relation is not empty. Meaning there exists at least one. Being a Boolean value operator, exists can appear in the where clause. So from beers that has name and manufacturer, find those beers that are the unique beer by their manufacturer. So here we have select star from beers where the manufacturer is equal to b1.manufacturer and name doesn't equal b1.name. So I got a lot of stuff on this slide here. So this is the set of beers from the same manufacturer as B1, but not the same beer. And then you'll notice that I have beers B1 out here, and I'm using beers B1 down here. So it tells us a little bit about the scope rules that are going on. The inner query has access to the outer query information. And if you don't mention the outer query information or the alias that was done here, you get the most current one. So, and also noticing the SQL not equals operator. The 2 arrows going this one says not equals. But notice the scope rule here where manufacturer refers to the closest nested from with the relation having that attribute. So manufacturer is talking about the beer's manufacturer. If wanted to, we could do same thing here as we did here. And that would be clearer. It would be a little clearer. So if we said from beers B1, and then down here we said from beers B2, and then we said B2 dot manufacturer is equal to B1 dot manufacturer, and B2 dot name doesn't equal B1 dot name, then we would be a little bit more explicit with what we're doing. This is done this way on this slide to show you that you don't actually have to do it that way. We have two separate beers, because we have beers as a table and then we have beers as B1. And it takes the scope of the entire query with all of the aliases and things you put together. If you got this one, you're doing pretty good. Or if this makes half sense to you, we're on the right track. So I see a lot of disturbed looks. It's okay. It has to marinate. By the end of today, you'll be like, oh yeah, SQL, I know that. X is equal to any. And we have any, and it's a Boolean, meaning that X is equal to at least one row in the relation, any of them. Similarly, you can replace it with the comparison operators. And instead of equals, it could be X is larger than or equal to any, smaller than or equal to any. X is not equal to any is true if and only true if the X is not in there. It's not equal to anything inside of the bag that comes back out of that. Or it's larger than or equal to all. So the not equal can be replaced with any comparison operators. Well, let's take a look here. Just to clarify, because I skipped through it, the all versus the any. Any is at least one. All is all of them. Got to equal to all of them. All those beers in there. Means that no row larger than X is in the relation if X needs to be larger than equal to all. So here's an example. From cells, bar beer and price, find the beers sold for the highest price. Wow. We just won the lottery and we want to buy beer at the highest price possible. So we want to find from the sales, what bar sells the beer at the highest price? So the subquery here is select price from cells. This is going to give us a bag of prices. $5, $2, $5, $12, $2, $5, $1. Randomly, because we're going to just select the price from all the entries in cells. No condition or anything. And this query is going to be in the opening and the closing brackets here. And then we're going to put an all in front of it. So the price from the outer cells must not be less than any price. So cells beer, select beer from cells where the price is larger than or equal to all of these ones in here. This is how we're going to get the highest price. If it's larger than or equal to all. Mm-hmm.
And the price is larger than all the price for the cells.
Yeah. So this in here is going to run first. This query is going to run first.
But it's from the same table from the cell.
It is. We're going to find the biggest one in there.
The next one.
Yeah. Larger than or equal to all of them. One of them is going to pop out as larger than or equal to. Because of the equal. You're only going to get one of them that comes out. One price. It doesn't gonna make sense at all. You're right. It's gonna be larger. Well, nothing's larger than if the biggest price in here was $10. That's pretty expensive for a beer. Actually, not if you go to one of these football games. $10 at sporting events. Okay, let's say $15 for a beer. Yeah, actually, I bought beer for $15 too. But let's just say $15. If the price that comes out here is $15 and this one's $15, it's never ever gonna be larger than. So yeah, equals is what's doing it. So if we said price is equal to, that probably would have worked. No, equal to all? No, it would be equal to all. We have to do larger than or equal to. Because it has to be larger than or equal to. It's not going to be equal. Well, anyway, you understand it. So this takes us to the relations. So believe it or not, we've gotten through a good portion of this. Relations as bags, groupings, aggregates, and database modification. That's what we're going to look at next. All right, don't freak out now. We have update. We have update. We have union, intercept, and accept. So remember those subqueries we just looked at? We were doing in a where, and we're getting a value from a subquery, or substituting in where something is equal to something, or something is larger than or equal to all of something. We just looked at that. Now we're looking at taking a query and crossing it with another query. So go back to algebra, and you go, if I have a set over here, and I have a set over here, set A and set B, I can put set A and set B together, and then I've got a union. So I'm looking for all items in both sets together. Or I can intercept them. Where do we have items that match in both of them? So remember, they used to draw in the circles, and then the circles kind of had one circle and had another circle overlapping it. And you went, oh, there's that little bit spot in the middle where they intercept, and we have, they're in both sets. Or then we have except. It's in here but not in here. The ones that are different, not the same. So just hold that from, I guess that was algebra or something. I don't know what that was. Discrete math maybe, I don't know. Set theory. It's relational algebra, I guess. Not really discrete math. So let's do an example. From relations, we have the likes table that has drinker and beer, and we have the sales table that has bar, beer, and price, and then we have frequents with drinker and bar. Find the drinkers and the beers such that, okay, the drinker likes the beer. Drinkers have to like the beer. And the drinker frequents at least one bar that sells the beer. I like the beer, I'm going to go to one bar that sells the beer. All right, so here's our solution. And just take this with a grain of salt. It's really one query intercept another query. We want to find where they're in both sets. So if I go back to what I was just talking about, they intercept. We're not unioning them. We're not putting union here, but we're going to put intercept here. We're going to find the cross between the two of them. This is the drinkers that frequent a bar that sells the beer. So like drinker, comma, beer from sells, comma, frequents, where frequents.bar is equal to sales.bar. That's going to give us a set. If you don't even want to bother understanding the query, you don't have to worry about it. Just take this as a query. It's going to come up with a set of results. And then this is going to come up with a set of results. The select star from likes is another set of results. And so we have one set intercept another set. And we can substitute the word intercept for the union and the except to get the three different combinations that we're looking for. Good. So far. Well, we'll see. By the end of the day, you're going to be like, I love SQL. Huh? Union takes them both together. All of them together. Union this set with this set. Yeah, and give me the biggest price. If I were to do a set of all bars and find out all the beers that are sold at all bars, and then all the beers that are sold that aren't sold, or all the beers that are all the patrons that go to all of these bars, I can find out where the beer patrons go, or the possible sets of bars that they could possibly go to by putting them all together. Yeah, there's a union on the intercept because you're just finding where they're similar in both. If you want to take them all together, find out where they're similar, or find out where they're not similar. If I could draw this, I'd draw two circles and I'd overlap the circles. And in the middle, where they overlap, that's the intercept. And then of the parts where they don't overlap, that's the except. And the whole thing together is the union. Union, hardly ever used. Intercept, used a lot. We want to find where these people who bought this product at our company, who did not buy that product, that would be except. If we were doing a query on a product, let's say we were selling accessories. Well, they bought the cover, but they didn't buy any mice. Where are all those people? We want to send them a promo, mice half off or something. Or let's say we want people who bought mice and they bought the cover, but they didn't buy the mouse pad. That's a union and an intercept. Or we want to go, people who bought computers and never bought any accessories from us at all. So they're not in this file over here. They're exceptions. They bought something, but they didn't buy that. Or something, I don't know. People who subscribed for the service but never used it. Where you're getting a mismatch in one set but not in the other. That's the, anyway, except. Bag semantics, although the select from where statements uses bag semantics. Remember, a bag is duplicates. The default for union, intercept, and difference is set semantics. It'll turn it into a set, which means if you bought 5 mice, you still bought only 1 mouse, because it takes the duplicates out for you automatically. And that's just these keywords will automatically remove the duplicates for you. But you can also do it yourself. So you can eliminate the duplicates by using this thing called distinct. It's a keyword you're going to stick in there. So if you duplicates are eliminated as the operation is applied. The reason why you want to remove the duplicates, if all possible, especially if you're treating the bag like a set, is if you've got 5 prices at $5 in there, and really all you're checking for is 1 price at $5 because you just want the number 5, you got to check it 5 times. So it's less efficient. If you go back from a data structures algorithms perspective, your sample group is bigger. If your data set's bigger, you have more entries you got to go through and check each one of them. It's a little slower. So if you remove the duplicates, then you're only checking 1 price. So it makes it run faster for efficiency. And if you get rid of the duplicates further down the aisle, further down the road, then it makes it run a lot faster. Controlling duplicate elimination, we can use the word distinct. Distinct will do that for us. So it forces the results to be a set of, it's set by distinct, select distinct. So to force the results into a bag, you can use the all, as in union all. So I have an example coming up. Here it is here. Example of distinct. So from cells, find all the different prices charged for beers. What price can you buy beer for these days? Well, let's select distinct price from cells. If I have $5 in there twice, I only get $5 once. I get $5, $10, and at the baseball game, $15. Or at the Levi Stadium, $15 for a beer. Actually, I believe they do charge $15 at the new stadium. So, you guys from out of town, you probably don't even know. I don't know, what do you guys buy beer for where you're at? Not $15. Well, no, they also sell hot dogs at $20. Would you buy a hot dog for $20? I don't think I'd ever eat a hot dog anyway, but if I did, I wouldn't pay $20 for it. You know, you could probably buy a whole thing of refrigerated frozen hot dogs for $1. Anyway, but I guess it's time and place. So. Notice that without distinct, each price would be listed as many times as there were bar beer pairs at that price. So distinct is giving us distinct. It's giving us 1 each. Well, here's our all. Because we naturally get a bag, if you accept all, union all, intercept all, then we get, because we naturally get a set, it'll turn it into a bag, which means give us all. So when you use all next to it, we got all of them except for, we're eliminating and we're putting the duplicates back in is what we're doing. So using the relation frequents and likes, lists the drinkers who frequent more bars than they like beers and does so as many times as the differences of those counts. Yikes. Now I think I need a beer to understand this query. So it says, select drinker from frequents, accept all, select drinker from likes. So we have frequents bars and drinkers that like beers. So they apparently they frequent more bars than they like the beers. Why would you go to a bar if they didn't sell the beer that you didn't like or you don't like? Don't worry about the query logic. If this were at 9 o'clock in the morning, you might get this, right? No, maybe not. Now we have join expressions. We can also join 2 tables together. I'm going to skip through the joins because we're going to use a different syntax with MySQL. We're going to do multiple query joins, so multiple table relation joins, where you can select an attribute from this table, comma, that table, which is what we've seen so far. It's an easier way of doing a join. But know that the join is used as an expression to put 2 tables together. Provides a number of expression forms using bag semantics, not set semantics. So it doesn't use the sets. You don't really need to know that. Expressions can be standalone queries used in place of relations in the from clause. For example, we have a natural join, a cross join. And as an example, here's a syntax. And again, I'm going to hit joins a little bit later with a different scenario. But here's the likes natural join serves. And the relation can be parenthesized subqueries as well. Natural join is going to put everybody together. So R natural join S. Or the cross join, you get that one and that one times together. So cross is multiplication. So if I have 10 rows times 10 rows versus 10 rows plus 10 rows added to it. So the query results are going to change depending upon the type of join you use. We have equality and we have inequality joins as well. And then we have condition joins. This is the equality, or they call it the Theta Join. This is the one I prefer using, but we don't actually have to use the word join. I'm going to show you an easier technique. But as an example, using drinkers and frequents, drinkers join frequents on name is equal to drinker. Theoretically, you want to join the tables on the primary keys if you're going to use one of these joins. Otherwise, you can run a query with a join and accomplish the same thing. And when we go through the exercises later, we'll kind of sort of see how that works. Because the joins are, you actually have to see the results that come out. As an example, let me just give you actually the left and the right, and the outer and the inner is what I'm going to do. I'm going to give you an example of that. Table A has 10 rows in it. Table B has 15 rows in it. If I join A to B, I'm taking B as the base with 15 and I join the 10 to it, I get 15 total. If I join the 15 on the one side to the 10 table, start with the 10 table and add the 15 to it, and I'm joining it by the keys, I get 10. They call one an outer, they call the other one an inner. The difference is on the inner, you're only getting the smallest number of rows that match. Example, if I have 1, 2, 3, 4, 5, 8 students, and I have 8 computers, I'm only going to get 8 sets of the combinations. That's the inner join. Outer join says take everybody. How many computers? I got 20 computers. So I got 8 students, give them all one, and now I got some leftovers. Well, they don't have a student assigned to them. They're just going to sit there. It depends on my query results whether or not I want the possible of all matches and then leave some blank, because what's going to end up happening is if I'm putting names on computers or something in that case, I'm going to have some computers without names. They're not assigned because they're extra, because I'm short. I only have 8 students and I have 15 computers or something. If that's the case, I can't match them together. In a perfect world, both tables would have the same number of entries. I'd have 10 rows here and 10 rows here, and put them together, I get 10 rows together. I'm joining the columns together. What a join means, this table data here, this table data here, making them so they're like one table. Which means if I have data for beers and bars that sell the beers, I can list it out in a query result, all the bars with all the beers they sell in one query to join the two tables, bars and beers together, and give me the matches. So hold that, tuck that away. We're going to see joins later on. So just know that you can join two tables together at this point. Also know that you can do aggregates. As an example, sum, average, count, minimum, maximum. So as applied to a column. So we can say count, and these are, I call them aggregations, but they're really functions. As an example, here's one. From cells, find the average price of Bud. So select average AVG. And now the spelling of this is going to be different for the database that you're using. So sum is usually SUM. Average might actually be spelled differently. And you're not going to memorize, what in the world functions do we have? You're going to find the ones that work. And look it up in the database documentation to see which functions are available. Usually there's a min, a max, a count, an average. Usually that's the case. So here's the average price. And it's going to give me one average price. So select average price from cells where the beer is equal to Bud. I'm only going to get one. Now if I say distinct, it's going to count up the distinct. So I can use distinct inside to say, for example, select count distinct price instead of just price. So if I have $5 in there twice, it's only going to count it once. So here's a number of different prices that charged for bud. Select count from sales where the beer is equal to bud. So that's going to give us only counting the ones that are unique. NULL'S are ignored in aggregates. So if I count up, like I was saying earlier in a sum, here's an example of what happens. If I select count star from cells where the beer is equal to bud, the number of bars that sell bud, and if I do this, count price, well, what if one of the prices is missing? Or one of the prices is null, I'm going to get a different count. That's why people will do this for a count instead of counting a price or counting a name. If you count up how many of a particular column are there, you're going to get, most likely you're going to get a different price if NULL'S are allowed. Excuse me, a different count, not a different price. So you want to be careful with the NULL'S. We also have grouping and we have having, and believe it or not, we're coming down the home stretch. Yeah, we're practically through the boring part of this. So you can do a select from where and express by a group by a list of attributes. So you can select the result from select from where and then group it. So here's an example of grouping it. And the grouping helps us determine what it is we're going to aggregate this by. For example, find the average price for each beer, and we're going to group it by beer. So select beer, comma, average price from cells, group by beer. Well, that means beer 1, beer 2, beer 3, with the average price is $10, $5, $12. Simple rule, if you put an aggregate on here and you put another attribute on here, you got to use the group by. Otherwise, you're going to get a database error. Because if you put an average here with a beer, how do you know you're going to, you would think that SQL would be smart enough to figure that out and just group it by beer, but it doesn't. You're going to get an error if you don't do that. So here's another example. So we have from cells and frequents. Find for each drinker the average price of bud at the bars they frequent. So average price from drinker, from frequents, comma, cells. And we just added a little bit of logic down here where the beer is equal to bud and the frequent sub bar is equal to cells sub bar. And then down on the bottom we said group by drinker. It's a little bit more complicated than the previous one, but it's the same example. We just drinker, group by drinker, and then drinker is how we're going to see the results. So this one's going to compute the drink bar price of bud, first row, and then group it by drinker. So restrictions on the select list, this is what I was telling you before. It has to be part of the aggregate or an attribute of the group list. So this one is an illegal query because the group by should say group by bar. If you're going to put something outside of the aggregate on the select line, you have to group it by that in order for the query to work. Otherwise, you end up with an error that comes out of it. You must think you can find the bars that sell bud the cheapest. Having may follow a group by clause. If so, the condition applies to each group, and the groups not satisfied by the condition are eliminated. What does having mean? Well, you can put it with a group. Having a condition is kind of like an extra where. Group it by this, having this. So the condition may refer to a relation or a row, and it has to be either part of the group by grouping attribute or the aggregate. So here's an example of having. From cells and beer, find the average price for those beers that are either served in at least 3 bars or manufactured by Pete's. Served in at least 3 bars or manufactured by Pete's. This is the worst query you're going to see all day. It's not so bad though. Having count bar larger than or equal to 3. That's not too bad. Or the beer is going to be in select name from beers where the manufacturer is going to be equal to Pete's. Group by beer from sales, and we're selecting the beer, comma, average price. It's not so bad. Maybe not. Not so bad. Database modifications. So insert, delete, and update. On the insert, we insert into likes, value Sally and Bud, or we can specify the attributes. This is what you're probably going to end up doing now. You're going to insert into likes. So now instead of select, all the queries we've seen so far started out with select. Now we have a group of queries that are going to start out with insert, delete, and update. These are simple compared to the select queries that we just looked at. These are like no-brainers actually. Once we create the table, we're going to want to insert stuff into the table. And this will come to light when we start populating tables. Another way to add would be to say insert into, and this is capitalized, but it doesn't have to be. Insert into likes, beer, comma, drinker, values, Bud, comma, Sally. So we can insert a query. So this is just a set of data. And we're doing it this way because we're going to specify beer and drinker. We could do it without it this way, but we'd have to remember the order that we're inserting. Yeah? You don't need to, they don't need quotes, no. They end up like that, but the values do need a quote, which is weird. Because these are the two columns that we're going to insert into. This is a more reliable query. It does the same thing as this one when we just leave out the attributes. If we leave out the attributes, insert into likes, value Sally and Bud, we can't go Bud and Sally. We have to remember how the table was created. If we don't remember what order the table was created, and we're going to look at that momentarily, we can't remember what order, and we can't remember how to insert it, then we're in trouble. And we end up not knowing what we're doing. Let's see. You can also insert a query. So you may insert an entire result of a query into a relation. So insert into a relation is subquery. So this says potential buddies, not pot buddies. So these drinkers at the bars are not smoking pot. We're interested now in potential buddies. So this generally wakes up people towards the end of the lecture when they go, there's not very much more of this, don't worry about it. But using frequents, enter into new relation pot buddies. All of Sally's potential buddies. Those drinkers who frequent at least one of the bars that Sally also frequents. So here we go. Insert into potential buddies. Select D2.drinker from frequents D1, comma, frequents D2. So we're doing frequents on frequents. So we're looking at the frequents table. We're going to find Sally, and then we're going to find all of the other people that also go to the same bar as Sally for her potential friends. So we're D2 drinker doesn't equal Sally, and D1.bar is equal to D2.bar. Same bar, all the drinkers, where it doesn't equal Sally. Because unless Sally wants to be friends with herself, which she could be. But we want to know all the other people that aren't Sally that frequent the same bars that Sally frequents. And then we're going to insert it into potential buddies. So it works out pretty good. Now, that's how you get data in. So you can insert it in, or you can delete it, or you can change it. To change it, you do an update. But let's look at delete first. You can say delete from the relation where first name is equal to something, last name is equal to something. So you delete rows that satisfy the condition. So delete from likes the fact that Sally likes Bud. Sally has decided she is tired of Bud. She does not like it anymore. We're going to take it out of the likes table. So delete from likes where drinker is equal to Sally and the beer is equal to Bud. So now likes is not having any record of Sally liking Bud, which is probably a decent delete when you think about it. I'm not really a fan of Bud, obviously. You want to get rid of everything, then you type in delete from likes. That will delete the whole table. Luckily for you, there's this thing called rollback. If you type in rollback, we can put everything back. Or there's this thing called commit. Commit will actually remove the temporary data that you removed, that you took out of this table. So commit makes it final. Rollback reverses. It's kind of like undelete in Windows. So delete from likes, where there's no clause, everything gets deleted. So here's a delete many rows. Delete from beers, all beers, for which there is another beer by the same manufacturer. So delete from beers B, where there exists. Select name from beers where manufacturer is equal to m.manufacturer and name doesn't equal b.name. So beers with the same manufacturer and a different name from the name of the beers represented in row B. The delete will go through one table to another table. I'm going to forget this. I'm going to forget the semantics because we don't necessarily need to know how the deletes are working. But the background stuff. It's just going to look for matches, and then after it finds all the matches, then it's going to delete everything. So it's a two-step process. Updates. This is how you're going to change data in the database. Update the table. Set a list of attribute assignments where a condition exists. For example, change drinker Fred's phone number to 5551212. So update drinkers, set the phone equal to 5551212 where the name is equal to Fred. There's no change. It's called update. So you got the, remember, if you walk away with anything, remember select from where, which is your query, basic query syntax, and then insert, update, delete. And then you get the whole language, technically. We're going to play around with this, and we're going to see how it works. You can update several rows, just like you can delete several rows. You can make $4 the maximum price for beer. So you can update cells and set the price to $4 where the price is larger than $4. That's a pretty good thing. You can automatically raise the prices. So now on this part, I'm going to skip for a second because we need software in order to actually, and what I want to do is skip the views and then go into making tables. But when we make the tables, then we can run the queries on the tables, which makes it a little bit easier. So we need to talk about software momentarily here. And the software we need to talk about is this piece of software here called XAMPP. So I'm going to log into this and show you what it looks like. Actually, you know what I'm going to do is I'm going to stop this recording, start it again fresh for those people who want to figure out, because this is really part 2 of the SQL. So let's stop this capture.